Hello, good afternoon. Welcome, everybody. My name is Paddy. I'm here on behalf of Elemental today. We've got with us a grand selection of speakers today, and we're going to be talking about the importance of improved indoor air quality. The session today is sponsored by Domus Ventilation, so thank you for that. Obviously, the air we breathe is integral to our health, and we spend a lot of time indoors. And with the current coronavirus pandemic, it's extremely important that we have good indoor air quality as well as our outdoor air. So if you have any questions or any chat, put them in the boxes below, and we'll get through them. We've got the speakers today. We've got David Frimpong from Domus Ventilation. No, we don't. Yes, we do. We have Ben Abel, who's here from Hilson, Moran. We have Clifton Gordon, who's from VentfiltersRus Limited, and Nathan Wood as well from Farmwood. So if you'd like to introduce yourselves, Nathan, we'll start with you.
Thank you. Yeah, Nathan Wood from Farmwood Emily Ventilation, working in and around the UK on all manner of ventilation systems and services, and have a key passion for anything indoor air quality related. Thank you.
Fantastic. And David?
Thanks. I'm David Frimpong. I'm the National Specification Manager for Domus Ventilation. We form part of the Climate and Ventilation Division for Genuit Group, which was formerly trading as Polypipe. So within the last few years, we all know how important IAQ has been, coming towards the foreground of public concern. So we're keen to discuss the best means of providing good indoor air quality in our homes, and also looking at the ways and means we can achieve that. We spend going on 90% of our time indoors, something like 60% within our own homes. Obviously, with COVID, that number would have jumped up significantly. So we at Domus, just wanted to engage with the market to discuss how we can ensure that good indoor air quality is achieved. Thanks.
Fantastic. And Ben, over to you.
Yeah, hi there. I'm Ben Abel. I'm Technical Director here at Hilson. We're an engineering consultancy. So my background is in building energy modelling. Obviously, as an engineering consultancy, we're interested in indoor air quality from perspective of providing a good design that is obviously efficient from an energy perspective. Giving good indoor air quality. We provide those sorts of services as well. So really just trying to come up with a design that meets all the criteria foisted upon us now with regulation, various sort of environmental standards like BREEAM and LEED and all the WELL. So trying to pull all those parts together when we look at design for buildings.
Fantastic. And last but not least, over to you, Clifton.
Yes, my name is Clifton Gordon. I'm the Managing Director at VentfiltersRus. We're a company that we specialise in installation, maintenance and service of ventilation systems. My background is in sales and in engineering, and one of my key passions is to ensure that ventilation systems are installed correctly. One of the main things that I've found since I've been in the industry, about 34 years, is that the installation tends to be quite bad with regards to ventilation systems, and a lot of manufacturers get the blame to say that their equipment is not good. But that is not the case. Predominantly it's down to poor installation and lack of understanding. So one of my main objectives in life is to make sure that ventilation systems are installed and maintained correctly.
Brilliant. Well, thank you very much. That's our panel for today. So we've got a selection of questions and topics to go through today. As I said, if you do have any questions, please do fire them away in the Q&A section, and we'll get to those and fire them at the panel also. So the breakdown of topics, start with question 1. And we're going to start with the importance of air quality and what this means for the ventilation industry. So could anyone give us a highlight on what is IAQ?
Yeah, I'm quite happy to jump in if you want, chaps. What is IAQ? Well, first of all, I think this is a huge opportunity for us to start and get things right. For far too long, we've been getting things wrong across multiple sectors in the building industry, but without doubt, ventilation is key for IAQ. Indoor air quality is the quality of the air that we breathe indoors, or indeed at the moment, the quality of the air that we exhale. We're worried about what's coming out, and at the moment with COVID, but we're also worried about what's going in. So we pay so much attention to what we eat. We've got calorie counter apps, you know, we've got different color codes on the food that we eat, all manner of variety of selection that you can have for your diet. Indeed, calorie counting with your fluids as well. But we just take for granted that what we're breathing in is of adequate quality. And whilst it's really hard to control the quality of the air that we breathe outside our homes and businesses, it's relatively easy to take care of what we breathe inside our homes.
Fantastic. Anybody else like to add to that? I mean, it's indoor air quality. That's pretty much summed up, Nathan. I think and what are the current regulations around it at the moment? We jump to you, David.
Yeah, thanks. So Nathan has introduced us into the topic very well. The current regulations around indoor air quality. You've got the UK air quality standard. LS law is also around the corner. It's sort of disappointing that we've had to get to that stage before any enforceable regulations have been put in place. The World Health Organization also set standards for minimum levels of NO2 and PM particulate matter for our indoor spaces. Now, building regs, in my opinion, don't go far enough in stipulating how we should address sort of VOCs. It gives us ventilation flow rates to work to, but I feel like we could go an extra step further. Still waiting on the government's environmental plan to be released. That's still in discussions, and I think that for us to make big strides forwards, we need to commit to a much more stringent target on indoor air quality and make it compulsory for house builders to deliver against those targets.
Okay, fantastic.
Can I add to that as well?
Yeah.
Of course.
So true with what David said, and although there's lots of guidance and what we should do, the World Health Organization guidance and everything else, my opinion is that there is no firm regulation for indoor air quality currently in the UK. Nothing that's really enforceable anyway, that's forcing people to do things. There are lots of changes afoot, as David has said, but I mean, the HSE it requires the workplace to have adequate ventilation anyway, but it's normally around sort of workplace exposure and occupational exposures rather than indoor air quality like we're talking about today. But there is something I would like to talk about is the work that's been going on with PAS 3003, so a publicly available standard that lots of people throughout the industry have been part of. We've got core members at BISA that have been part of that as well. The good news is that the British Standard Institute have realised the vital importance of this PAS and the work that's gone on with it. So they will have fast-tracked that through to BS 40101. There's too many. BS 40101, I think that's right. So yeah, I mean, shout out to David Kest on that as well, and the amount of work that him and his team have done in the EFT consult. That's all coming together. But again, we've just got to streamline it and get things right. It's great that we're rushing things through, but things have just got to be on point. So when that comes through as well, and as David said, Ella's Law, the Environment Bill, revisions to approved document F, everything's building up and heading in the right direction for sure.
Brilliant. And what's the sorry, carry on.
I was going to say, just also the Institute of Air Quality Management have just released a draft document on, how to do air quality monitoring, assessment, and modelling, which is a consultation at the moment. But that sort of sets out a very sort of clear methodology of how we should do these sorts of things. So, it's become a vital interest of the industry, and it's good to see that lots of different groups are putting forward methodologies to how we do those sorts of assessments, because up to now it's been a bit sort of smoke and mirrors. Certain people have done it certain ways, and nobody's quite sure of, there's WHO guidance, there's UK guidance, but there's no sort of very defined methodology of how you frame these sorts of problems. So it's good with the BS and with this document to look at how we actually can convert these sorts of assessments into meaningful results.
Okay. And just while we're on the topic of indoor air quality, what do you think is the main cause for the change in indoor air quality, given the housing, the housing stock at the moment? What's having the biggest impact on indoor air quality, do you think?
I mean, personally, I think it's the drive towards low energy. We're designing much better insulated, much more airtight buildings, and our sort of ventilation strategies have not, and technology has not really caught up to it, and the house building industry is not really switched on to how to do this in this country. If you look into Europe, the Germans, other bits of Europe have been doing this for decades. They know how to do it. We're on a bit of a catch up in that respect, and so it's our push towards zero energy, zero carbon, sort of improving our housing stock and our building stock in general. The building fabric and our servicing strategies are lagging behind in some cases.
Definitely to add to that as well, Ben, you said that these buildings are being sealed up. We've been sealed in these boxes, or renovations are then taking old leaky buildings and sealing them up as well. It's us. We're the problem inside the building most of the time. Regardless what you're bringing from outside, our very living, breathing, operating within these spaces are a huge problem. Drying clothes, not using ventilation systems, not using kitchen canopies properly, not maintaining these systems properly. Oil-based candles, deodorants, hairsprays. There's so much to it that in a sealed building adds on it day after day after day, part of your normal routine. And even in a new build, the glues, the paints and the materials that they use continue to give off quite harmful toxins and VOCs. And if it was built in the winter months, once it comes to the summer months, they're going to change and react and potentially produce more. So there's a real balancing act to be had.
Yeah, fantastic. So we just had a quick question come in, actually, and this is from Sarah Deakin, just saying, will using heat recovery mechanical ventilation systems be adequate to provide good enough air quality in a warming world? Any thoughts?
I'm prepared if no one else is. Sorry, I feel like I'm jumping in all the time. Yes, they will. I mean, David can probably jump on this in terms of the tech behind it, but there's summer bypasses. So if you've got a heat exchanger there, you're not always going to be adopting that heat exchanger. They're automatic. They bypass the incoming air, so you don't get the uplift of the air coming in. The filters that are on most MVHR systems are designed to look after the actual parts themselves inside, but you can get enhanced filtration as well. So if you are in a poor air quality area, you can adapt. And as long as they're designed in properly and implemented properly, MVHR is a great solution.
Yeah, I think, I'd like to add to that. Yes, MVHRs can help to provide excellent indoor air quality. Specifically in a warming world, as Nathan mentioned, the units come with summer bypass facilities. And in essence, the air is not recovered via the heat exchanger. You just get ambient air from outside delivered into the space, which means you're not recovering all the warm air from the use of your home, showering, cooking, etc. Now, it's also important to mention that how each manufacturer, each MVHR supplier delivers the summer bypass facility is not the same. Even within a single manufacturer, you might find that some bypass the heat exchanger completely, while others slow down the incoming air. And it's important that as we model solutions for indoor air quality and looking at MVHR systems, that we specify and design the systems as best as possible to ensure that they deliver against what the remit was. So from a consultant's point of view, when they're specifying a unit, most MVHR units will tick generic boxes, but it's important to understand how that unit actually works, how it performs, how it installs, and how it will fit in with the building itself. Even looking at filtration, some units filter on both the supply and the extract side of the MVHR. Others only do it on the supply. So it's vitally important when we're talking about indoor air quality and mechanical solutions that we can use to solve some of those issues, that whatever we do propose is well specified, well designed, and integrates well into the building as well.
One thing I'd like to add, in my own experience, is that in terms of air quality, heat recovery systems, won't work on their own. I work a lot with retirement buildings, in retirement developments, and one of the biggest problems that we find is that the buildings are overheating. So the buildings have been built well insulated, and the problem that we're finding is that even with a heat recovery system with a summer bypass, you're still experiencing temperatures which are totally unacceptable, well in excess of 30 degrees. I was at a development yesterday and it was exactly the same. And what we're having to do to compensate is to install additional cooling, i.e. air conditioning. Now, my view is, that's almost counteracting the issue. What we need to do is focus on the building design so that the buildings are designed adequately, so that with a heat recovery system or a ventilation mechanical system, you are then getting the air changes that you require and not just relying on that for cooling.
Yeah, Clifton, I'd agree with that. I mean, the MVHR can provide, your fresh air, and they can be designed to have a boost mode, but that isn't going to be sufficient in a lot of cases now to overcome the overheating. So yeah, it's imperative that the buildings are designed correctly, the windows are sized appropriately, and then there's the issue, if you're using openable windows to get your summertime overheating ventilation, obviously that mitigates any air quality issues you've done through a nice filtrated MVHR system. You're bringing in the outdoor air. So it's a difficult problem because we're being forced to design buildings that are low energy, low carbon, meet all these requirements, and obviously the overheating standard is looking like it will be brought into the update to building regs. I'll probably jump on a question or two here, but yeah, the update to building regs, which is going to happen end of this year into force middle of next year, means you will have to provide an overheating assessment. At the same time, we've got to try and meet our air quality and our noise and all the other, all these counterproductive issues that are all fighting against each other. So it's a really tricky problem.
Just to add on it again with that, but the developers tick the box. It's BREEAM excellence. It's whatever it needs to be. He's been paid. He's off. So the problem now is left to the building owner, or whoever's in the space. And I do feel that, again, over in Europe, they go back and they reassess, is the envelope working? Is the design working? Once real human beings are in it rather than a computer simulation. And the word retention is a dirty word in our industry. I'm not a fan of it myself, but I do feel that certainly there needs to be some leverage to say, if you've designed it to X and we're getting Y, it's coming out of somebody else's pocket. And I do think the change in regulations will force that.
Yeah, I mean, certainly in the non-domestic market, they are moving towards a operational building assessment model. So once you've finished the building, you have to go back and check that it operates, as you said it would, which puts a lot of onus back on designers, installers, etc., to do it properly. That's not happening in the domestic market so much, because obviously it's much harder for every individual house built owner to go back and do that. And there's all the issues around, when it becomes a council owned, property, things like that. So but that's the point we need to be. We need to be producing buildings that perform, as we say, that as they've designed, to give people confidence that they're going to get good air quality, no overheating, daylight, all the things that we promise, and the affordability issue comes in. If we're moving to an electric, low carbon economy, if your building doesn't run as you've designed it, you're going to end up with a massive electricity bill, and people will start screaming about it.
Okay, so someone mentioned there about sort of putting the onus on the homeowner to sort of regulate the impact that, well, they had to follow what's going on with the air standard in their house. But we've got a question from James Graham who says, what plans are there to articulate the indoor air quality standards in a user-friendly manner to the end user? So for example, occupants, workers, teachers, etc. So is there anything that can be laid out clearly for those types of people?
there is already some guidance out there. SIBSI, Breathing Buildings, BISA, and alike. Probably all names and words that you probably not heard of. But there's, if you want to have a Google for VG002, I mean, maybe we can share this later on the back of it. It's some basic guidance laid out by the team at BISA in terms of all of the COVID mitigations for indoor spaces. But even on a more basic level, if you went on to Global Action Plan, looked at their website, there's some great free resources for students and teachers there. You've also got UNICEF. They're doing some fantastic stuff with schools information, and it's stuff that would benefit the teachers and the students as well. And I do think engaging at that level at the moment, because there's lots of worry about children going back to school. Do they need to wear masks? Do they not need to be wearing masks? Parents are petrified, because for us to reactivate and go back to work, we need our children safe in schools. I think there's a lot more that needs to be done there, but we could fill several webinars talking about school air quality. So I think we'll just park that one.
Yeah. I'd like to add as well that the government has released updates on best practices for indoor air quality in terms of leaving your mechanical ventilation systems running if possible at boost rate to try and encourage air changes in your space. But at the most sort of more basic level on a domestic building, on a new build, developers typically provide handover documents to occupants once they're moving in. And within that should be good scope for how to maintain their mechanical systems within their homes. And that can inform end users on how often they need to replace filters or check on the unit. And additionally, most manufacturers do supply I&Ms with their products to ensure that end users are able to maintain the unit. So.
Yeah,
One of the problems is it's difficult to know when you have bad air quality unless it's something very obvious. I mean, if it's hot, you can look at a thermometer and you can say, "Oh, look, yeah, it's 28 degrees in here." If your bills are high, you can look at your energy meter. There's lots of smart meters out there. I mean, the technology is coming. Air quality meters, the costs are coming down and down and down. So, it's going to be, I'm sure someone like a Ring or someone like that is going to, you can get these sort of these devices. You connect your internet, you get feedback from it. Like I say, once the housing providers start providing the information, people will have that to their hand and say, actually, my air quality is bad, and they can, and the guidance is there to follow. So they can say, oh, actually, it's poor because of, and hopefully we can start giving people guidance of what causes the bad air quality, and give them that feedback. Yeah, you're drying, you're burning your toast. It's the simple analogy, but there's things like that. So I think the technology will hopefully provide the solutions.
We've had another comment from Justin Cheng. Is there not also a problem that sometimes the occupiers, the building owners, they don't understand how the modern mechanical ventilation systems are working? Is there an element of that involved as well?
Take that one. I'll say yes. Again, in my experience, there's lots of apartments that's been sold. If we just speak about in the London area, they've got mechanical ventilation systems in there. There's no information on the systems. One of the companies that I worked for previously, a company called Expel Air, they sold many heat recovery units into London, and we've been called out now because Expel Air don't offer that service anymore with regards to maintenance. And I've been to buildings which are 11 years old and they've never had a service. When you go in and speak to the occupant, they say, well, we don't know what it is. They don't know what it does. There's no information about it. So they only find out that there's an issue when they've got mold growth or damp or condensation. So there is very little information available, particularly with apartments, with properties which have been sold, and there's no information available.
All right. Well, we'll park that there. We'll move on from that. Now, obviously, we've been unable to escape the impact that COVID and the pandemic has had on many industries and many areas of life. But we'll touch on how COVID has impacted the way we think in how the ventilation and etc. for new builds and indoor air quality in new builds. So how has it impacted in the way we're thinking in terms of the quality of homes and how we build new homes regarding good ventilation?
I think the changes coming with approved document F, that's going to force a lot of people's hands. I stood up at a seminar a few years back and called for open collaboration between all sectors in order to make positive change. But there's one thing that the manufacturers would do. They build to a spec or a standard. And this is a spec or a standard, they're not going to change. You look at BB 101, Building Bulletin 101 came out. Suddenly every manufacturer overnight had a hybrid ventilation system ready and on the market the next day. So if there's a requirement for people to have intelligent heat recovery systems for domestic properties that can work with an open source IoT air quality monitor, boom, overnight we will have it. To add to that, there needs to be a cross-sector upskilling. I mean, we've got a natural lack of training going on anyway across all sectors, you know. But without question, people will start to tick boxes to make a standard rather than understand the full impact of what actually is going on within a building. I hope that answers the question a bit. I went a bit off piece there, sorry.
That's all right. Then obviously there's been a lot of mention on people sort of overheating in their homes, and obviously is there anything that we can do to sort of alleviate that? Is there any way that certain different types of ventilation or any other solutions to help, you know, the risks that come with overheating in homes?
I think we sort of jumped ahead on this question a little bit and started discussing it a little while ago. I think to effectively deal with overheating in homes, we first have to make sure that the build is correct. So we have to look at the orientation of the building to ensure maximum solar gain, but also allow for shading. We have to look at our fabric as well. And once you've modeled all those things, and Ben will be able to speak a bit stronger on this than I can, but once you model all those things, you can ensure that you deal with overheating at the early stage of the build. Clifton mentioned a site he's been to with overheating issues and having to add in cooling. I'd imagine, you know, quite possibly that's because no shading or little shading has been allowed for within that build to ensure that occupants are able to achieve thermal comfort. The changes in Part F that are upcoming also include an overview on overheating. So where previously we just used SAP to lightly assess the risk of overheating within a home, the new regulations now require a much stronger onus on designers to fully verify that a building will not overheat, either via modeling of CIPSE TM59 or via providing adequate cross ventilation within the design of the building itself. So I think when it comes to overheating, that is how we tackle it. You know, passive house designs fully focus on those elements of the build first before we start to look at mechanical solutions or mechanical cooling or any other means of dealing with overheating in homes.
Yeah, I mean, there was the existing building regulations, the existing SAP assessment tended to give you benefit for having a lot of passive heating in the winter to reduce your domestic heating load. That tended to sway people towards letting more light and heat into the building, which then gave you overheating problems because that wasn't a requirement to be assessed. As David mentioned, it was a very simple overheating assessment, whereas now they're asking you to do either a full dynamic modeling of your building or to follow the sort of the simplified assessment guidance. So I'm just gonna wait for this plane to go over. And I was involved with LETI, the London Energy Transformation Initiative. So part of the response to the overheating assessment, we did some testing to see if those simplified method limits they put on there were appropriate. And broadly, they were for outside of London. What we found for inside London, and I think this would be analogous for any urban environment. I think that the problem was that the London weather file is quite onerous. The ones outside of London are basically taken from airfields outside those cities, so Manchester, Birmingham, etc. So they're not quite, they don't have that urban heat island effect. So what we found is, yes, London, those guidance generally worked. So they gave minimum percentages of openings and windows and stuff. As rather than having to go down a model, it if you're a small volume house builder or something, you can say, well, as long as my building doesn't have more than this amount of glazing, then it should comply. But what we did find is actually they tended to set maximum levels of glazing. What we found for bedrooms is actually there was a minimum level to ensure that for nighttime ventilation, when you're trying to sleep, you have a big enough opening to purge that hot air out of the space. So there's some nuances within it, as with any new regulation, that we're going to find some slight hiccups and stuff as we because it's the first time this has been introduced. But yeah, it's really key to get that design advice, as David mentioned, orientation, shading, the right amount, the right specification for your glazing, getting that fabric right, and then obviously when you're applying, then you won't need to open your windows too often, and your MVHR and your ventilation system can work as designed, and that will help ensure that the air quality in your home remains as good as you can. I mean, the other thing is, the big question is, should we really be building in urban environments? The problem is that in our cities, all the spaces that are left are those tricky plots that were by a road or by a railway. All the good plots of land have gone. So we're on these brownfield sites that are really tricky to develop. So there's a moral question: is just because we can build, should we build?
Yeah. To add to that again, now we've spent the last sort of 18, 20 months, it feels like forever, dealing with COVID. The end is near, but not quite yet. And it also sort of opens that question of remote working is a real possibility for a lot of people. So when we think about how we build our homes moving forward, the impact of COVID, the opportunity is there to not constrict ourselves so much in the type of sites that we build on. So we can look at building slightly outside of the sort of the urban area, and to try and reduce the cost and then the energy cost of building in such constricted areas. So on top of looking at the IAQ, we also have to consider the energy that we're using to deliver that, the areas in which we're building, to ensure that we are achieving the best efficiency.
We've actually had another question come in from Sarah Deakin, which was linked to COVID, and she's asked, do we think the mechanical ventilation systems will provide a good enough rate of ventilation to help deal with airborne viruses such as COVID and possible future infectious diseases? I mean, it's quite a specific question, but I think I'm sure someone might have an answer.
I would suggest that it will. Again, providing the system has been installed correctly, and there are different grades of filters which would provide some assistance. But I still fundamentally believe, in terms of ventilation and indoor air quality, that you may still need rapid ventilation, because the MVHR system will only be able to deliver a certain rate. And one of the problems that I find as well is that to get, when it's on boost and you're having a shower or you're cooking, that is acceptable. But to have the MVHR system on boost when you're trying to sleep is not going to be acceptable for most occupants, unless you've got a really good design and you've located the MVHR system away from where you're sleeping. So in answer to the question, I would say yes, but maintenance is vital. There's no good having a ventilation system and it's not been adequately maintained.
I'm going to go against you then. I'm going to say no. And if you'd have said no, I would have said yes. I think you're right in what you're saying though. If it's operated all the time in boost at the higher rates, then yes, but no one's going to do that. You're not going to sleep with an MVHR on in boost. Because the regs are built in such a way and the designers make these systems in such a way to meet minimum requirements. Everybody aims for the bare minimum and they install most of the time to the bare minimum. We can have ventilation systems do huge amounts of airflow. You know, as long as they're designed and installed correctly, you know, you can have an MVHR on your desk, you won't even know it's running. You know, there's as David said, different manufacturers make things different ways and they use their analysis and testing data differently. I think that's fair to say. Leave that there. And it's just a way in which a lot of people won't understand what that white box in the cupboard is. You know, it's a bit noisy, we've turned that off, don't worry about that. As long as I've got my heating and hot water, that's fine. But in terms of whether or not MVHRs would be adequate in COVID times, they weren't designed for COVID times. However, I do feel that if you're able to overventilate the space by leaving it in boost in the short term, then yes, but I would recommend looking at HEPA filtration as well. But you can't just bolt a HEPA filter in line with an MVHR and expect it to work the same way.
We've had quite a lot of information regarding new builds and what, you know, the possibilities that we can do to affect the air quality in those. We've had a question from Tabitha Evans, which says lots of interesting information, but she wants to know, how does the panel see the standards being implemented on more retrofit projects as opposed to the new builds? Is there any difference between the two?
That's the sort of elephant in the room, isn't it? It's, you know, new builds are nice and clean. You got a blank bit of paper. You can design it as you want it. You know, you look out there, 90% of all the buildings are already built, and most of them need some sort of retrofit to meet, you know, the net zero and all the other things. So it's a very difficult question, because every house, every building, you know, there's such a wide variety amongst the building stock. It's, you know, it's a very difficult question. So yeah, the retrofit is really, really tricky, because no two solutions are going to be right for two different properties. It's you know.
Okay, great. And so just it's a bit of a sidestep here. We got another question in from Oliver Cooney. Then, in terms of monitoring the indoor air quality, would using CO2 as a proxy for air quality be worth expanding in the future? For example, in Scotland, he says they have monitors which are already installed in the main bedroom by regulation. Would expanding this UK-wide provide homeowners a basic indicator of their indoor air quality and how well the ventilation system is working? So, you know, would using CO2 as a proxy be worth expanding in the future?
Yes. Leave it there. Next question. No, yes, it will. But the only thing is, CO2 sensors cost quite a bit of money. You know, a lot of sensor manufacturers would use an alternative sensor that's cheaper and then use an algorithm to work out roughly what the CO2 should be. And also, if you are actually using a CO2 sensor, depending on the type, it can actually degrade over time. So if you're spending the money on a CO2 sensor, why not spend a few pounds more and get something that monitors VOCs, that monitors temperature, humidity, ozone, you know, NOx. So yes, we do need to bring those in. Without question, they're going to be, as somebody said, like, you know, your smart doorbell or whatever else. The posh white phones, they're developing an integral sensor. Being careful trade names here. But yeah, I mean, without question. And also CO2 monitors, of the Department for Education have sponsored them in Ireland. There's talks for them to be sponsored to schools in the UK as a proxy for COVID. But let's look beyond COVID. If you're investing in something now, why not have a sensor that can cover a lot more to look after us in the future?
Okay, yeah. I hope that, is there anyone to add to that? Sorry, before.
Yeah, I just wanted to add to that. It's been a lot of talk about ventilation rates and how they're able to deal with indoor air quality, CO2 levels and NO2 levels. And yes, 100% sensors are critical to be able to inform the user of what is happening within their home, so that they can actively make an effort to correct it. But I think it's also important that we look to builders to subscribe to schemes like the home, the home quality mark, which provides a set of guidance for ventilation rates, which is over and above building regs in Part F. This means that the higher ventilation rates is able to provide better mitigation against poorer indoor air quality in homes, and also where NO2 filtration is required, developers have a responsibility to let home occupiers know when they need to be replaced. Because over the last sort of 2 or 3 years, we've seen a lot of them installed in buildings which are built next to roads, and that's great. But how many of those have been replaced since? Very few. So I think we have to ensure that we subscribe to some of the schemes that are already available to us before we look to new schemes and new tools to fix those problems.
Fantastic, thank you, David. So, is there just final topic regarding COVID? What are the market trends for ventilation and indoor air quality at the moment? Is there anything that stands out as being a broad solution across the board?
Yeah, air purifiers, specialist filters developed by NASA. Lots of snake oil out there as well, in terms of what works and what doesn't work. You've really got to dig deep, I must admit. I've had some fantastic presentations. Let's go on. Sorry, Wendy, I'm live. And then it's all about the filter tech, how they pitch that going forward, what they're using, how they're using it. MERV-like filters I've seen as well, but without doubt, air purifiers, additional filters for MVHR, etc., and air quality monitors, they're on trend.
Perfect, thank you, Nathan. So if we move on then, so how can we deliver on design intent and improve the installation of the systems? Obviously that ties in with the builders and the people building new homes, but what is it that's causing the poor installs of these systems? Is it lack of information on the builders, or lack of budget, or is there what are the causes of these poor installations of ventilation?
I'll take that one. I think lack of system design and pre-qualification. In my experience, sometimes ventilation is an afterthought, or it has been. Since COVID, it's becoming more and more to the forefront of people's imagination. But predominantly, I find that there's no actual design for the ventilation system itself. What I find again is plumbers, electricians, and that's not decline plumbers and electricians, they will take that on as an additional part of their package to do the installation. And they say, well, it's only a fan, it's only a bit of ducting, so therefore we can do that. They don't follow the actual design and realize that at the end, it needs to be measured and verified. So I would suggest that it's a lack of design system initially for the installers. And also as well, it's a lack of training and experience of those installers themselves. As I say, I'm a believer that, if you want a plumbing job, you'd call a plumber, you wouldn't call an electrician. If you want an electrician, you wouldn't call a plumber, and vice versa. So when it comes to ventilation, when I'm on site, we get a lot of ridicule to say, well, is that an actual trade? It's only a bit of plastic, it's only a bit of ducting. But when the building is complete, those same people are calling you back to say, well, this doesn't work. Why doesn't it work? And you go through the process, and it's because it's poor installation and lack of experience. So I would suggest it's key, to have installers which are qualified, they've been verified and proven that the work that they do is good.
Can I add on that, Clifton?
I think
Sorry,
there's also a lack of, as we've mentioned before, lack of verification and a lack of enforcement. I mean, the poor building control guys, I've had utmost sympathy for them. They are asked to check 1 million things on site, and they haven't got the powers to slap people on the wrists when they do things wrong. And even when they do, they're so small that the developers and the house builders, it's small change. They'll just pay the fine and they'll move on. there's not enough, the penalties aren't onerous enough to make people do things properly. And that would help a lot, I think.
Totally agree with both of you on that. 100% behind you, Clifton, as well. To become a competent domestic ventilation installer, you have a 2-day course, and then you're free to install. I know you can fast track any course, but there's a lot to be said about the standards that are currently there. They are under review, as everything is at the moment. But I do think you need to do that course. It gives you basic understanding of the do's and don'ts. What you do after that is up to you. But the trouble is, as you said, Ben, building control come out. It's intangible. As long as they've got that cert that says the airflows, and then it meets design, away you go. And then in Rocks, Clifton and myself, it's all gone wrong in years to come when you're taking the ceilings down, taking MVHRs off the wall, and starting the process all again. That's where we're at a lot of the time.
Yeah, I'd agree with that. I think the amount of training that's available to installers needs to be improved. But also from our point of view as manufacturers, what we do try to encourage is the use of semi-rigid duct systems, which have compression fittings. So you don't rely so much on the people on site in terms of gluing and taping to ensure continuous seal on the system. When you look at passive house design standards, it actually looks to move away from the use of tape as a means of jointing plastic ductwork systems together. Now, that way you can ensure the least resistance, and know that once your ceilings are up, you're not going to have any leaks that have to be retrospectively fixed. Or quite recently, what I had with Nathan, you might find that your ducting, whether that's flex or plastic, has been crushed by other services, also on the flex side, to be fair. So I think the use of the right systems at design stage to try and reduce the onus on site is absolutely critical as well.
Nathan, you mentioned that you can get this training done in a 2-day course. Are there more robust checks that
There are. Yes, there are, by the same organisation that trained you in the first place. And they will come out and they will go through your insurances, and they will check your certificate for your anemometer that you have to pay, was it, Clifton, 350 quid for a good anemometer these days with a matching hood?
Yes.
And then you take them to a site of your choice for them to verify the installation's okay, and they go to site with your engineer, they take a photo of the serial number, and then they don't even ask you to take an airflow. And this is, oh my God, be really careful. Other organisations, very, very similar, will do electrical competence testing. And you talk to an electrical guy or a gas guy, when they're being questioned, they are sweating. They've swatted up on the book the night before. They go to site and they're questioned until they get one wrong. And then they look to make sure that the electrician will refer back to the book, find the right page and give them the right answer. They know that people can't retain all of this. And that's why they've got this Bible in the back of their van or on their phone on an app. We need the same thing with ventilation, 100%. Oh, and they charge you about 350 quid for the privilege of having the heightened CPD version on your wall that no client will ask for, because anybody can install domestic vent. I could go on.
I'm with you.
Yeah, man. We need to get into training. Let's set up a training course. Let's go. It's the way of the world at the moment. It will change. Things will change. Things will improve, I'm sure.
I think it's because it's seen as well a soft side of air quality, overheating. Because gas or electricity, you get it wrong, people can die. You get these things wrong, people do get ill and die, but it's not immediate. That's the it's the same with. It's almost analogous with COVID, because people don't if COVID was you touch someone, they are going to die. People would be a lot more careful, but because it's you can't see that effect immediately, people are less careful. So having that training and verification is the only way to do it, I think. So
okay. And finally, on this section of improving the installation of systems, are there any corrective measures that we could use within the existing housing stock? What is the options there for everyone?
I think one of the things we can do, with existing systems, is to actually go and test them. You know, if you go and test to verify that the systems are delivering, whether it's a system 1 fan or it's a MEV or MVHR, it's very simple to be able to go and measure to see what it's actually doing. In my experience, you know, you've got a design intent and a desired airflow, desired air changes per hour, but the reality is often different. And I think it's very simple to go out and do an assessment on a property to say, well, okay, what would it be? You know, we can look at what the design values were and see what the actual values are and do a comparison. And then, you know, you can actually offer some form of improvements. Generally, again, in my experience, systems are turned down because of noise, and the noise is high because of poor installation. So there's always a reason, but it's always things that can be fixed. You know, where there's a will, there's a way. That's my belief. And you can always, you know, providing it's not drastically wrong, you can always do something to actually improve the air volume and reduce the noise as well. So I would just say you need to go out to existing stock if there was a problem at a property, go and do the initial checks, do the measurements to see what the air volumes are, and then make adjustments. And 9 times out of 10, what I find is that they haven't been adequately commissioned. The paper says, yes, this is what we achieve, but the reality is that no one's actually put the flow meter on and actually measured it.
Yeah. I think I'd echo that as well. I think we've been called out to sites where people have complained about the condensation forming, and sometimes you've gone to site and what you found is that the duct is not connected to anything at the end of it. You know, the terminal is just connected to free air, and therefore no moisture is being taken out of the property. So for existing stock, I think it is absolutely critical, like Clifton said, that we go and assess what the current issues are, whether that is poor installation or mechanical units that have failed, and address that. And I also, you know, I'm a believer that system 1, intermittent fans, on-off fans, don't perform as well as continuous extract mechanical ventilation. So this is quite a simple upgrade we can do to encourage air changeover within our homes. So that is a small action we can do when people are remodeling their homes, or if any councils are looking at retrofitting existing stock. That is a very simple approach that they can take to move from system 1 on-off mechanical ventilation to continuous extract. I believe they perform significantly better in condensation control.
Okay, fantastic. So the final topic, really, we've got a couple of minutes left, just regarding the maintenance of these systems. How much of it is the responsibility of the homeowner, and what education is there for them to help, you know, keep on top of the air quality within the homes?
I suppose with regards to whose responsibility, it all depends on the setup. You know, if it's like a rented accommodation where it's owned by the local authority, you know, I would suggest it's more down to the local authority and having a planned maintenance scheme involved. If it's a private end user, then it falls more down to the actual homeowner themselves. And one of the key things is education. There's lots of people that are living in properties that they really just don't know. And it's not just ignorance, they just physically don't know. So it's all about how do we educate people into understanding that if you've got a ventilation system, it needs to be maintained. You know, if I asked anyone on the panel, have you got a boiler in your house? Do you get it maintained? All of us would say yes. It's something that we do on an annual basis. So a mechanical system, it's like a car. Does it need servicing? Yes, it does. And it's getting that information out to the end users to say, well, we've got this bit of kit and it needs to be maintained.
But like a car, you get that manual that comes with the car and you toss it. When you get your new apartment or whatever place you move into, chances are you're going to get a home information pack or some sort of pack, which someone spends a lot of time and money putting together, because without that, they're not going to get paid. Stuffed in a drawer, forgotten about, because everybody expects I'm going to have radiators on the wall or on the floor heating, a boiler, a distribution board, and that white box that I don't know what it does, but it's really noisy, so we turn it off in the corner. We need to raise the importance of what this system does. That system is your building's lungs. And if that doesn't work, you're going to get poorly. The condition of the building is going to degrade over time. and the building's going to cost more to operate in anyway. You know, these systems are designed to work in harmony with each other. But yeah, 100% education for end users, 100%.
Just to add to that as well, I believe in Scotland, mechanical ventilation systems need to provide fault indication where they're installed away from the end user's sort of visibility. I think that is something that would be useful for us to adopt here in England, to ensure that, you know, even where the home user is not aware of how the ventilation system works, if they're not taking the time to read the information pack, that fault indication is positioned in a clear and obvious place so that they can go back to the units should it pop up. The same way your boiler gives you an error code, your mechanical ventilation should be able to provide you with fault indication, so that at the very least you can speak to a ventilation expert to look at how you can remediate the problems that you're having. Yeah.
Fantastic. Well, it's obviously a very important issue, and one that obviously needs looking at across the board from both perspectives, from the understanding of, you know, people in their homes and their understanding their own air quality, and putting the onus on the providers of the ventilation to give education on those types of things. So if there's any last comments, any last things you'd like to say, just to end us out, anybody? There's no pressure. we can leave it. Thank you very much, everybody. Clifton, David, Ben, and Nathan, thank you so much for taking the time out to talk to us today. So on behalf of Elemental, and thank you everybody for all your questions. It's been a great, quick flowing discussion. So thank you to Domus Ventilation as well for sponsoring the talk. And you can follow this back on demand on the website, on the Elemental Talks page. So thank you very much, everybody, and enjoy the rest of your afternoon, and take care. Thank you very much.
Thank you.
Thank you.
Thank you, guys. Cheers.